Hello my dear students, welcome to one more amazing session from Infinity Lane. How are you all doing? Please confirm, can you all able to hear me, can see me? आज हम चर्चा करने वाले हैं quantum mechanical model of an atom. So in the atomic structure you have two parts. One is a classical atomic model. Whatever the Bohr's atomic theory we studied so extensively, it is up to this classical atomic model. So the classical atomic model says the electron existence in a definite path. After the dual behavior of the matter and the Heisenberg uncertainty principle comes into the picture, so the existence of an electron around the nucleus you can't definitely can say. So that you have to introduce the quantum mechanical model, that is what is called modern atomic theories. So the quantum mechanics is nothing but your modern atomic theory. It is the bridge between the classical model and the modern atomic theory is the Heisenberg uncertainty principle. आज हम चर्चा करने वाले हैं द क्वांटम मैकेनिकल मॉडल, उसमें डी ब्रोई कॉन्सेप्ट, हाइसेनबर्ग अनसर्टेनिटी प्रिंसिपल एंड श्रोडिंगर वेव इक्वेशन. इन दैट wave mechanics and radial probability distribution curves are very important for NEET examination. So hi Saumika, so stay tuned, please attend this lecture throughout this live and please like this session, share with your friends and subscribe to Infinity Lane NEET YouTube channel. This is Suresh, Faculty of Chemistry for you, and we are presenting the quantum mechanical model of the atom. Hi Yashir Mir, hi everyone, thank you for liking the session. Those who are online, please like the session. So before going into this quantum mechanical model, I just want to introduce this core examination, India's largest scholarship examination. Anybody right from grade 3 to grade 11 you can do this, and this is a hunt of the bright talent across India. Sri Chaitanya is offering score examination, India's largest scholarship examination. Bacho, in that is just why it is India's largest scholarship examination. इतिहास में नहीं है, अभी तो है 2.5 crore cash rewards. Believe it? Yes, we are the one of the unicorn in the education industry, Sri Chaitanya Academy, and we are offering 2.5 crore of cash rewards and 350 crore worth of various scholarships, bacho. And in that you can see, have you ever dreamed about going to NASA, United States of America, to just for a visit? Yes, the deserved persons are taken to the NASA trip, and also exciting gadgets like tablets and laptops are there with you, and get ready to get as many as you can, and also up to 100% scholarships are there. Why late? Register now. In the description box link is there and you can register. This core examination can be offline and online. You can sit at your home and you can write the examination, and you can go to nearest any Sri Chaitanya Academy centers, and prior to the availability you can write the examination. And this examination is of two versions and two slots. One is on October 28th and October 12th and September 28th. So registrations are open for September 28th examination. You can register up to September 26th, and October 12th examination you can register up to October 10th. है ना? Right? So why late? Link is available. Can just description box in the pinned messages, and you can click it and you can enroll and enjoy all possibility of the gadgets and cash rewards and all scholarships and NASA trips and everything. So get as many, grab as many as you can. All the best, my dear children. Here one more important thing, NEET test series. Only two promotional slides for today. Okay, right. So whenever you prepare for any examination, you need to know where exactly you stand, isn't it, right? And if you ask any topper for the reference for the NEET to 2025 is completed, you can ask your toppers, they say they prepared well like you. What makes the difference? Yes, it is they undergone very good number of tests, and that is designed, scientifically designed NEET test series, this ultimate and secret to key success. And just it is for the grade 11 and grade 12 and repeaters. You have three different packages, and these packages are actually designed by NEET top level faculties from the Infinity Lane by Sri Chaitanya Academy, and you know it is based on the latest NTA examination pattern, and also it simulates the real time test taking experience dear, so that you can do the best. And Violet link is available in the description box and the pinned messages, and you click it and you can purchase this, and when you apply YouTube 30 of coupon code, you will be getting automatically 30% discount in that. So it is going to बहुत सस्ता में मिलेगा आपको. Yeah, hi Esirmir, all the students who are online, just एक बार like button दबाओ, and we'll talk about the promotion is over. We'll talk about the quantum mechanics. Violet here, the pathway to quantum mechanics. So far, the Bohr atomic theory says the electron existing in a definite path. That gives you it is existence, and quantum mechanics says you can't do that because it is impossible to measure the exact position of the electron or the momentum simultaneously. So that is given by important developments, dual behavior of the matter and Heisenberg uncertainty principle, and these two are the foot-holding step for the quantum mechanics. Hey, yes, I am going to explain you this in brief and this in brief, and today's class I want to give you certain tricks. You may say that a Schrodinger wave equation is going to be so complicated, and आज हमारा क्लास में Schrodinger wave equation थोड़ा सा कंसाइज करके एग्जामिनेशन में कैसे इस्तेमाल करना आपका बताना चाहता हूँ. Okay, Soumik Saham and Esirmir, yes, come on, let us see. He is De Broglie. De Broglie he says the particle when it is moving, it has both wave nature as well as a particle nature, and this is called duality of the matter, and it is true for any particle in motion. It could be a big particle, it could be a small microscopic particle, but this is only applicable and considerable for the microscopic particles like in electron, right beta? And this can be explained on the basis of the wavelength of this electron is directly proportional to, inversely proportional to its momentum. So lambda is inversely proportional to momentum, and the lambda is equal to h by mv. H is called Planck's constant, and mass is the m is the mass of the particle, v is the velocity of the particle, and you can also say h by p. What is h over here? Planck's constant, that's value is going to be 6.626 into 10 power minus 34 joules second. Mind it, this is in the SI unit, right? And also this is going to be given, De Broglie prediction was experimentally verified by Davison-Germer experiment. What is this Davison-Germer experiment? When the light is projected on a particle, X-ray is projected on a particle, it is going to give a scattering pattern. Even electron, beam of electron is also projected on the same crystal, it is also scattering. The scattering pattern is observed is going to be the same. That is what is called Davison-Germer experiment. In that you can see the De Broglie equation with related to the kinetic energy is given. So short notes you can make it, take a note, and these short formulas you can write it directly. You can go ahead with this calculation, because most emphasis I just want to give the orbitals and the shapes of orbitals and nodes, nodal planes सब आना चाहता हूँ आज क्लास में. Stay tuned बच्चों. So the kinetic energy and the wavelength can be calculated based on this formula. So the kinetic energy, mass into velocity is equal to root KEM. So by applying this, the kinetic energy and the wavelength are related to, here the wavelength is equal to h by root 2 kinetic energy into mass. M stands for the mass of the particle. You know the kinetic energy of the particle is equal to Q into E. So Q is the charge, and QV. When a particle at rest is applied with a potential, it is going to accelerate. So applied potential is going to be V, and Q is the charge on the particle, or E is the charge on the particle. So the wavelength is equal to h by root 2 QVM. So V is going to be accelerating potential beta, and E or Q is going to be charge, m is the mass of the particle. So how do you do with this calculation if comes into the electron? I have a simple trick. I just want to say, for electron, it is a simple formula, or you can say wavelength is equal to 12.3 upon accelerating voltage, ताकि आपका वो wavelength you are going to get in angstrom units. You know, 1 angstrom unit is equal to 10 to the power of minus 10 meters. So when you do NEET examination, this is the simplest technique you can use it, or otherwise wavelength is equal to under root 150 by V. Definitely the voltage will be given, accelerating voltage will be given, you can calculate the wavelength. And the ratios also very important, beta, ratios also very important. And you can say here wavelength of de Broglie equation lambda by h by mv, and you can say if a cricket ball, if you observe a cricket ball, mass approximately 150 grams and the velocity is 25 meters per second, assume it is a spin ball, not a pace ball, huh? And if we want to calculate a wavelength 6.626 into 10 power minus 34 upon 150 into 10 cube, 10 power minus 3 kg में convert किया, 10 power minus 3 into 25, and on doing so you are going to get 1.7 into 10 power minus 25. इतना कम value consider नहीं करेगा. It is not considerable. 10 to the power of minus 5, who will care this value, है ना? If you apply this de Broglie theory for an electron, electron value is 9.1 into 10 power minus 31 kg. So electron moves with high velocity 2 into 10 cube, let us assume it, and if you calculate the wavelength, it is coming to be 0.364 into 10 power minus 6 meters, or otherwise 364 nanometers. So 364 nanometer is mathematically considerable value. When this value is so considerable, I would say this is going to be applicable when it comes to the microscopic particle like electron. चाहे आपको electron मान को, चाहे आपको alpha particle होगा, चाहे आपको proton भी होगा. When it comes to the bigger particle, right? Jaiwala, hi, Saumika, wanna say something? Okay, so for this value is not considerable. So cricket ball जैसे macroscopic particles के लिए ये considerable नहीं है. Okay, for electron it is going to be considerable, but it is true for either sides, right beta? Now let us say here, when the electron is moving around the nucleus, according to the Bohr, electron revolve around the nucleus in a circular path. But according to de Broglie, it is going to be in a wave-like motion. So in that wave-like motion, my dear children, which is correct? So it is a standing circular wave-like motion. So the circumference of this wave 2 pi r is equal to radius is equal to n into lambda. So n is the integer based on this principal quantum number. I mean to say it's a shell number. Wavelength is going to be lambda. And this is true based on this Bohr's theory. Again, it is considered to be corrected. Yes, it is correct. Bohr said MVR is equal to NH by 2 pi. But Bohr eventually said that, but he cannot explain why MVR should be equal to NH by 2 pi. Yes, this is the wave-like nature can help us to prove, yes, again MVR is equal to NH by 2 pi. And I just want to say, when the electron wave is in the phase, n lambda is equal to 2 pi r, है ना? So where n is the number of waves and made by an electron in the Bohr orbit. So number of electrons made by a shell number is equal to the shell. So one wave can be made in shell K shell. Okay, 2 waves will be made in shell number 2, 3 waves will be made in shell number 3, 10 waves will be made in 10th shell, right? That is the key point, can help you a lot. And when it is talking about MVR is equal to NH by 2 pi, okay, MVR is equal to NH by 2 pi here. So n lambda is equal to 2 pi r. So lambda is equal to 2 pi r by n. Also we know that Bohr, what de Broglie said, lambda is equal to h by mv. So can I take this 2 pi r is equal to h by mv? Both are lambdas, am I right? So that I would say 2 pi r by n is equal to h by mv. So simply mvr is equal to nh by 2 pi. ठीक है. So again quantization of angular momentum है ना, Ashermer, Saumika, Jayalva. So take this, again quantization of angular momentum is seen. Now I just want to say number of waves made by the electron in the fifth Bohr orbit of hydrogen atom. Can somebody tell me in the chat box what could be the answer? Can somebody tell me? So जैसे questions NEET examination में बहुत काफी important है. I'm expecting an answer in the chat box. Bachcho, come on. So the number of waves made is equal to number of waves is equal to shell number. This is the trick. In the class, I am going to give you all kinds of tricks so that you can simply answer this. So it is n is equal to 5 ताकि आपका answer 5 हो सकता. Are you getting or not? And also, what is Heisenberg uncertainty principle? I don't want to give you a lot of unwanted like boring kind of stuff. आपका जितना चाहिए ये नीट एग्जामिनेशन क्रैक करने के लिए उतना कॉन्सेप्ट आपको देना तैयार हूँ. गेट रेडी एवरीबॉडी और ऑनलाइन, प्लीज लाइक द सेशन. So what is Heisenberg uncertainty principle? And he is the one who has given this. He said it is impossible to measure the position and the momentum of the electron simultaneously and accurately. So it is impossible. He proved it mathematically. So and if we want to do by using some practical, so electron has to be visualized by using a high energetic light. It will have the shortest wavelength, so that when the electron trying to be located by light, the electron is going to absorb that energy and is going to change its place. That's the reason why you can't measure its place. That's what it is said to be. And if you want to do its position, you are going to get error. And if you want to do the velocity, you are going to get error. How much error you are going to get? It is infinite. That can be given as mathematically delta x dot delta p should not be less than h by 4 pi. NEET examination, it is so precise. It is so precise. And you have to be clear on the fundamental aspects, my dear students. Okay, be clear. Now delta x dot delta p is greater than or equal h by 4 pi. What is delta h? And delta x and delta p. Delta x is going to be uncertainty in its position, and delta p is going to be uncertainty in its momentum. And it is also written that delta x dot m delta v. So why don't you write delta m delta v? M is a mass. The mass is always a certain value, it's not uncertain. So delta x m delta v is greater than or equal to h by 4 pi. So m is the mass of the particle, and delta h is going to be, delta v is going to be uncertainty in the velocity, where h is going to be Planck's constant 6.626 into 10 power minus 34. Okay, dear students, let us see if I wanted to calculate position accurately. If position is calculated accurately, so उसमें uncertainty 0 होगा, error 0 होगा, then delta x is going to be 0 and delta p should be h by 4 pi dot delta x. So delta p should be greater than h by 4 pi into 0. Anything by 0 is going to be infinity. Can you believe it? Some value is greater than infinity. Do you accept this value? Mathematically, is this value is permitted? Yes, of course it is not permitted. Therefore, once you measure the position accurately, you can't measure the momentum, and vice versa will happen. Okay, so those students, this is a live interactive session. If you have any doubt, you can use the chat box, you can discuss with me any subject related things, and in this session I am going to give you the motivation. I just want to give you the suggestions, tricks, tips and everything. Fine beta? Right. So let's go ahead with this quantum mechanical model. So once you said it is not possible to measure the position of the electron, and you can say electron is exactly there, it is not permitted. But you can say exactly is not there, but it is there inside the atom. Therefore, you can say electron may be present, probably present. So probability concept will come. So in the wave nature, I just want to say what is the significance of psi and psi square. When the electron is moving like this, it is just like a wave. So when this electron in this path, it's a three-dimensional wave, and this is what is called as amplitude of the wave, that is called as a psi. It is written as a curve and it is crossed. And psi is a wave function. It gives the amplitude function, and it can be positive and it can be 0, it can be negative. So it cannot be negative. The probability values lies between 0 to 1, and the probability value cannot be negative. That's the reason why psi square is taken. So square of anything, you know, it is going to be a positive value. So it gives the probability finding of an electron around the nucleus. And this is how the wave nature of the electron is seen. Psi value is here, it is a positive quantity, it is a 0, and it is going to be negative. So negative values has no physical significance. Now NEET examination में ऐसे theory questions कैसे आना संभावना है. So which of the following is true? Psi has no physical significance. ये सही बात है. Are you getting or not? So like that you learn the things in such a way that you should be so precise when you answer the questions. Bacho, and moving ahead, psi square, Schrodinger wave equation. So Schrodinger wave equation is given as dou square psi by dou x square, dou square psi by dou y square, dou square psi by dou z square plus 8 pi square m by h square of E minus V of psi is equal to 0 आता है. इतना बड़ा इक्वेशन है. पहले चीज है, इतना बड़ा इक्वेशन देख के आप डर मत ना. ओके, आप डरते हैं? नो नो नो. डू यू हैव टू डेराइव दिस? आई से नो. सो डू यू हैव टू डू एनी न्यूमेरिकल बेस्ड ऑन दिस? आई से नो. So this Schrodinger wave equation is a equation given by Erwin Schrodinger, Austria, and this equation gives existence of a electron psi along the x-axis, existence of a psi by virtue of psi along the y-axis, existence of psi along the z-axis. Bas. So when you solve this equation, just memorize this equation, kuch nahi hoga. You are going to get existence of an electron by using x, y, z axis. That is what it is said. X, y, z are coordinates. Simply it is a mathematically it is a Cartesian coordinates, bachcho. Stay tuned. After 5 minutes, I am going to show you the animations of various orbitals. Right? So here m is the mass of an electron, h is a Planck's constant, E is the total energy, V is the potential energy, and psi is the wave function of the electron. So this is a mathematical equation of the second order differentiation. Okay, in this mathematical equation, you are going to get the solution for the psi along the x, solution for psi along the y, solution for psi along the z. That's it. Okay, so to say that, I just want to say, when you solve Schrodinger wave equation, so this is your x-axis, this is your y-axis, this is your z-axis. Okay, this is your nucleus. When you do so, you are going to get an x, y, z. So let us solve the electron probability finding may be here. To say may be here, you need two things. One is the distance between from here to here, that is called radial probability, right? And the angle between here and here, it is going to give you angular probability. By taking this, the electron existence can be taken here. So this is your electron existence. So electron existence probably may be solved like this. So on solving this, multiple times you have to solve this equation, not you, and it is solved like that, and the probability finding of an electron is seen here. Okay, how it is seen? Look at this. This is an x-axis, z-axis, and this is your hydrogen atom. Once this hydrogen Schrodinger wave equation is solved, probably electron may be found here. Again you solve it, probably electron may be found here. Like that, hundreds of times you just solve it, so that you are going to get the electron probability finding. So this is the mathematical image manually drawn those days in 1910, 1915 it seems. So you are going to get a spherical shaped probability dots, that is called s-orbital. Are you getting or not? This is how the atomic structure is unveiled. Bacho, this is very important. I just want to show you shapes of various orbitals. Okay, and graphs is important for NEET examination. Ready for that? Okay, so that is a different matter. I don't want to indulge into the boundary conditions and everything. And I just want to show you the quantum numbers, and after that shapes of orbitals. Yes, shapes of orbitals, right? Any doubt, bacho? Any doubt? And those who are online, please like the session and subscribe to Infinity Lane NEET YouTube channel, so that content and the good lectures are going to be delivered for the free of cost for you. Attend the lecture and lage raho. Aap acha karna chahta ho to kar lo. And here boundary. So the radial probability that is given as d, that is going to be 4 pi r square dr psi square, and the dr is the thickness of the subshell. So I mean to say here, you can say this is the nucleus and somewhere the electron is found, okay, and with a difference. So this is your dr, this is your dr. So electron can be present anything between this differential distance, right? So how much density is there? That is called radial probability density. You can see here, you can see for s orbital, you can have 3 types of graphs: psi versus radius, psi square versus radius, and d versus radius. There are 3 types of graphs. When you talk about s orbital, can accommodate 2 electrons, L is equal to 0 beta, and it is given as 1 s orbital. This is the nucleus, this is the nucleus, and this is the dots 1s orbital. It is a spherical shape. And you know the probability finding of an electron where it is maximum up to 95% is called orbital. And the probability finding of an electron where it is 0 is called as a node. Let us talk about the 2s orbital. This is the nucleus and this is the 1s orbital, and this is your 2s orbital. So there are 2 spheres, one is wrapped on another, and there is a gap where the electron is not found, that is called as a node, and that node which is a spherical in shape, that is called as a spherical node. That is what is called as a spherical node, right? And you can say this is the nucleus, 1s orbital, 2s orbital, and the 3s orbital. So there is a gap between 1s and 2s, and there is a gap between 2s and 3s. So this is the picture about 3s orbital, and there are 3 spherical nodes. There is a node which is spherical in shape. This is called spherical nodes. How to calculate spherical nodes I am going to show in the next slide. Okay, that is very, very important. Dear children, let's talk about the total number of peaks appearing in the curve for the s-orbital. You have two types of graphs. So, radial probability density and this is your radius, and the probability 4 pi r square dr psi square. And from the nucleus you can say, from the nucleus this is going to be increased. The probability density is maximum and it is decreased. The maximum is measured at 0.53 angstrom units, that is your hydrogen atom. Understood? That is your hydrogen atom. And there is no node over here. So, the total number of peaks. You can also say here, this is your D versus R. This is your D versus R. But show NEET examination, these probability curves are very important. Probability curves are important. Now, let us say psi and psi square. Psi and psi square. So, 1s orbital, the wave is coming down, right? And 2s orbital, the wave is coming down and getting up. And this is the probability finding of an electron where it is going to be 0 is called as a node. And 3s orbital, it is coming down and it is up. So, there are two nodes. There are two nodes. This is your node. Understand? So, a graph will be given and you will be asked which is the 1s orbital, which is the 2s orbital. Now, I just want to talk about psi square. Now, I just want to take the same graph and take psi square and radius, psi square and radius, and it is a psi square and radius. Look at this. So, whatever it is coming, psi and r, psi square and r for the 1s orbital will be the same, but psi square, it cannot be negative. So, whatever it is coming here, it is flip it to the positive side. That is the trick, so that it is going to be 2s orbital and this point is called as a node. Node means electron probability is 0. Are you getting or not? This is a very, very valuable information. And you see, 3s orbital, it is coming to be like this, okay, and it is going to be like this. So, it cannot be flipped, right? It cannot be down. That's the reason why I just want to say this is 1s orbital, 2s orbital, again 3s orbital. So, this is going to be a node and this is going to be a node. There are two nodes. Here two nodes. So, this is the psi square. Always you remember, this is the one. And what about 2p orbital? Psi versus radius. So, it is going to be 2p orbital, right? And it is going to be 3p orbital, it is a node. A trick, s orbital, the graph should start from up and coming down. For p orbital, it is starting from origin and going up. That is a trick. Everybody please take a note. For s orbital, the psi versus radius, the graph is always coming down, always psi square also. While for p orbital, it starts from origin. Understood? It starts from origin. So, you want to take psi square versus radius and it is going to be 2p orbital. Psi square versus radius, it is going to be, this has to be flipped up and three p orbital, there is a node. Are you getting or not? So, the graphs will be given. Based on that graph, which orbital you have to identify. I have a couple of questions to explain you that better. And you have the number of nodes, you have to calculate it. Now, these are the graphs I just want to show you here. Now, let us talk about the probability density curves. probability density curves. So for this probability density curves, you see the psi square, no? Probability density versus radius, probability density versus radius, and the probability density versus radius. Dear students, you compare between psi square and psi and psi square, and I am comparing psi square versus probability density 4 pi r square dot dr psi square. Now it is going to be 1s. It is always starts from probability density, always starts from the origin and from 0, and it is going to be like this for 1 s orbital. And you know the distance between these two? You know the distance between these two? 0.53 angstrom units for the hydrogen atom. These graphs are very important, beta. These graphs are very important. Writing or not? Writing or not? Right. If you have any doubts, please let us know. And this is the one, 2s orbital, it is coming like this. Okay, this is your node. This is for 2s orbital, this is for 1s orbital. You know, as the shell number increases, peak height also increases. Shell number increases, peak height also increases. This is the extensive explanation I am giving you based on the quantum mechanical model. Definitely 2026 NEET examination graphs based questions will come. Really believe me and take a pen and paper, write these graphs and noteworthy points that I am giving you. And I witness this type of explanations can really impact your NEET examination preparation. Dear children, take care. Now, let's talk about the 2p orbital. It is going to be like this again. Okay. And as n value increases, shell number increases. Right. Now, let us talk about the p orbital. It is, what is the shape of p orbital? S orbital spherical, p orbital dumbbell. You have three orientations. L value 1. M value starts from minus L2 plus L including 0. So that minus 1, 0, plus 1, these are the three valuable, these are the values are permitted. And you see, you have the 2p orbital, you have 3p orbital, you have a node. This is your node, right? And also this is your d orbitals, this is your, so number of peaks is very important. Okay, so the number of peaks, it is only for d orbitals. Before that s orbitals are there, s orbitals का graph उसमें नहीं देख रहे. So अलग अलग देख के आपको probability density is shown here. Now you have d orbital, it is a double dumbbell shape. You have dxy, dyz and dzx and dx square, y square, dg square. And these 5 d orbitals, now I just want to show you f sub shell. So d orbital shapes are very important. So dxy, dyz, dzx, you can see dxy. Simple way to learn the shapes of the orbitals. Okay. So you have dxy, mean to say x-axis, y-axis, between lobes are there. This is what is called dxy. And you see dyz, xy is over yz. So y-axis and z-axis. And dzx, z-axis and x-axis. Okay, let it be whatever. And you have, there are two orbitals, that is x and y. So this is x square, y square. This is x square, y square, and this is g. And I just want to say this is a collar. Appear like a p orbital, but it is a d orbital. The d orbital, dg square, this is called dg square, dz square, you can say x square minus y square. Okay, dx square, y square, you have to pronounce it better. Now, there are 5 d orbitals where there are three orbitals dxy, dyz and dzx are the three orbitals in which where these lobes are present in between the axis, right? While dx square, y square, dz square are along the axis. Are you getting or not? So you can find the nodal planes over here. I am going to explain you f orbital. It is going to be L is equal to 3. So m is equal to -3, -2, -1, 0, +1, +2 and +3. 7 orientations are there. Okay, and it is quadri-dumbbell shape. So these are the quantum numbers. I just want to show the various shapes of orbitals, Later I will take you to the graphs again. Exactly. Can you see? This is your s orbital. Spherical in shape. Bacho, it is in the spherical in shape, right? It is spherically symmetrical. It has no directional. It is uniformly distributed along the x-axis, y-axis and z-axis. Any doubt, bacho? So I just want to show the orbital like this. Let us talk about the p orbital. This p orbital has a, we usually write this p orbital like this, right? Okay, this is your px orbital. Okay, but actually px orbital lies as a two lobes, and there is a significant gap between these two lobes, that is the px orbital, right? And you can just put some paper between these two, that is a plane that is called nodal plane. I just want to show these nodal planes as well. And this is a pz orbital and this is going to be py orbital. So p orbital has, p subshell has three orientations, px, py and pz. Are you getting or not, bacho? Are you getting or not? Well, fine. Jailova, Saumika, Yashirmir, those who are online, if you have any doubts, you can ask by using chat box. This is an outstanding presentation, and this is going to be dxy orbital. This is going to be dxy orbital. Along between the x-axis and the y-axis, the shapes are being seen. It is a double dumbbell shape. And you have dyz orbital, bacho, and you have dzx orbital, and you have dx square and y square. You see the orbital is present along the axis. And also you have dz square, okay. So these are the various f orbitals that you actually don't need to learn. There are, you see how many lobes are there? You have 6 lobes that you can, 8 lobes you can see, right? 8 lobes you can see. Various orientations are there. These orientations is absolutely not required. That's the reason why I don't want to give much emphasis over here. Okay, now valuable information in today's class in the NEET examination point of view, it is important. What is a node and various types of nodes and how to identify the nodes and everything is given here. Bacho, a node is a point or region where the probability of finding of an electron is 0. If electron is there, you can say it is an orbital. If electron is not there, it is said to be a node. Generously, it is a node. A node can be a point where the electron is not there, is a nodal point. A surface where the electron is not there, that is called nodal surface. Area is electron is not there, nodal area, nodal region, or a plane, nodal plane. Okay, you can say a sphere, a nodal sphere. So that is how many nomenclatures are there, but you have only 2 types of important things. One is a spherical node, another one is a angular node. There are 2 nodes, right? That's very important for the NEET examination point of view. So far 6 times the NEET examination questions has been asked based on this node. Let us discuss about this. So a radial node, So what is a radial node? Let us say this is 1s orbital and 2s orbital. This is 1s orbital, this is 2s orbital. This is called node. A gap between 1s sphere and 2s sphere, right? And that sphere has the spherical in shape. So that is called as a spherical node. That is called spherical node. The sphere has a radius now. It is also called as a radial node. Simple. Simple, right? Array 2p and 3p orbital. You can say this is your nucleus, this is your 2p orbital, and this is your 3p orbital. And between these two, node. This is called spherical node. Are you getting on? Even for the orbitals, d orbitals, you have the same. You try to understand what is a spherical node. But so here, this is what is said. So this is your 1s orbital, 2s orbital, this is your 3s orbital. I could find the probability of finding of an electron. Here it is 0. That is what is called as a spherical node. So how to calculate the spherical node here? This is a radial nodes can be simply calculated. Radial node or a spherical node can be calculated by using n minus L minus 1. N is equal to principal quantum number, L is equal to azimuthal quantum number, and 1. You all note this? You all note this? Fine. That's fantastic. And talking about calculating the number of radial nodes for the 1s orbital. Apply the formula. For s orbital, L is equal to 0. So n minus L minus 1. N minus 0 minus 1 is equal to 0 nodes. Right? And also, I just want to calculate the number of radial nodes present in 2p orbital. So radial nodes or spherical nodes, both are same, na? Yes. So it is going to be n minus L minus 1. So 2p orbital. L is equal to 1. So 1. 2 minus 1 is again 0. I want to say 4d orbital. How to calculate? So for d orbital, L is equal to 2 and n is equal to 4. So I just want to say spherical nodes or radial nodes is equal to n minus L minus 1. 4 minus 2 minus 1 is equal to 1. Happy Janmashtami, Betu. How are you? You came late. I'm missing you. Betu, how are you? Okay, namaste. Thank you. And how many are there for the 3D orbital? 3 minus 2 minus 1, 0. There is no nodal, what I say, radial nodes or spherical nodes. Okay. Chatki, hello, hello, hello. So, hope you understood this concept. Hope you understood this concept, बच्चों. So, अभी लगे रहो. अच्छा concept आपको देने वाला हूँ. Angular nodes. What is this angular node? So, let us talk about the p orbital. This is your nucleus and this is your px orbital. And in this p orbital, there is a plane which passes through the nucleus where the probability of electron is found to be 0. It is called as nodal plane. This is what is called as a nodal plane. So this is a plane, right? Plane has an angle. So this is what is called as angular nodes. This is what is called as angular nodes. Beto? Right. This is angular node. Simply this is also called as a nodal plane, and these angular nodes can be calculated. You can see this px orbital. This is a lobe and this is a lobe between a plane where nodal plane is seen. And also you can see this is a py orbital and this is going to be a nodal plane. NP stands for nodal plane. PZ orbital, you have this and you have this. Between these it is called as a nodal plane. Are you getting or not? Are you getting or not? And even for the d orbitals, आपको दिखाना चाहता हूँ. for this you see, for example, for s orbital L is equal to 0. So you can calculate number of angular nodes, is equal to its azimuthal quantum number, So when you see here, number of angular nodes can be seen. So number of angular nodes or nodal planes is equal to L. L stands for azimuthal quantum number bachcho. L is equal to 0, it is s orbital. L is equal to 1, p orbital. L is equal to 2, it is going to be d orbital. L is equal to 3, it is going to be f orbital. Right? Hi Ashok, hello. You like the session? Just एक like button मारो. Okay, session का जोश बढ़ जाता. Ashok Gaming, most of the students who are regularly attending the class, I appreciate them, but try to be on time, learn the process and take the noteworthy points, right? And as s orbitals इसका L value 0 है, 0 angular nodes होगा. For p orbital L 1 होगा, इसका 1 angular node होगा. Hi Sonali, how are you? पढ़ाई कैसे चल रहे हैं? For d orbital L is equal to 2 angular nodes are there, right? So moving ahead, for the d orbital iska no problem Ashok, no problem. Look at this, for dxy orbital you can see a nodal plane between these two. Between these two nodal planes are there for the d orbital. Two nodal planes are there, right? And dxz again you can see. Are you getting or not? Clear? And dyz, and you are going to have the nodal plane like this, dx square y square. Two nodal planes are there like this in front of you. Sonali, hope you understood. Ek like button maro yaar. Now this is the story. Everybody gets confusing. What is this? Everybody, you can see here dz square. It is a dumbbell, around that a collar is seen. That is a dumbbell, around a collar is seen. Now you can see a cone shaped nodal plane is seen. Here it is another cone shaped nodal plane is seen. Yes, there are two nodal planes, but cone shaped nodal planes are there. That's very, very important as far as these d orbitals are concerned. NEET examination, it gives you the information about the nodes. Based on the nodes, you will be having a question. Calculation of total number of nodes. How do you say the total number of nodes, beta? The total number of nodes is nothing but the sum of radial nodes and angular nodes. Okay, so number of radial nodes plus number of angular nodes. Radial node का formula क्या होगा? n minus l minus 1 बेटा. Angular node का l होगा. दोनों मिला के क्या होगा? n minus l minus 1 plus l. So if you take these two, you are going to get n minus 1, that is the total number of nodes. By taking this total number of nodes, you can predict the type of graph also. I am going to give you certain questions based on that. We'll do that questions, right? Stay tuned, get ready. I am going to present these questions. First of all, let me give you an example. Calculate the total number of nodes of the 2s orbital. For the 2s orbital, L is equal to 0. है ना, n is equal to 2, n minus 1 bus. So 2s orbital, the value of principal quantum number is 2 and L is equal to 0. So the total number of nodes n minus 1, 2 minus 1 is equal to 1. That's it. How do you visualize this? Nucleus 1s orbital and this is going to be 2s orbital. This is your radial node Rn. So simple. If you get confusion, na, it will lead you into the infinite confusion. But there are only two things: radial node and what I say nodal plane. Okay. So radial node or spherical node n minus l minus 1 and nodal plane or planar nodes or what do you say angular nodes, that is equal to L. So दोनों मिलके n minus 1 ही होगा. So I just want to show you the correct, it's a question, it is a question that you are going to expect for the NEET examination. it you are going to get a NEET examination. Read the question properly. I just want you to give the answer. I want you to give the answer. So this is how the questions are going to be landed directly in the NEET examination. Let me read this question for you and answer the question. Okay, just let's see here. The correct radial probability distribution curve for the hydrogen atom of the orbital with the principal quantum number n is equal to 3 and azimuthal quantum number n is equal to 1. So n is equal to 3, L is equal to 1, that is going to be 3p orbital. Okay. So the radial probability density versus radius, which of the following is true? And this one it is indicating, and this one is indicating for the p orbitals. This could be 2p orbitals, it could be 3p orbitals, it could be 4p orbitals. This is not possible because as the n value increases, the height of the peak increases. So this is invalid curve. And 3p orbital total number of nodes, you are going to be total nodes is equal to n minus 1. 3 minus 1 is equal to 2. 2 nodes are there. You can see 1 node and 2 nodes. Therefore, I would say option 2 is the correct answer. Simple na? It is pretty simple na? Like that you are going to get a questions from the NEET examination. Perfect. Betu, Ashok, Shatki, Sonali, if you have any doubts, please let me know. Right, one more question. The given radial probability distribution curve represents which of the following orbital? Answer? So it is going to be 1 node, 2 nodes. So 2 nodes are there. It could be 4p orbital. So total number of nodes, if it is a 4p orbital, n is equal to 4, L is equal to 1. So n minus 1 is equal to 4 minus 1 is equal to 3. So 3 nodes are not there. So it cannot be 3p orbital. It is going to be 3p orbital. Understand? So 2 nodes are there. So 3p orbital. So n minus 1. So total nodes is equal to 3 minus 1 is equal to 2. So it is correct. Fine. You are getting the trick to understand this, right? And also we have various things, and also I just want to say, in this probability distribution curves, one thing you need to understand, as the n value increases, look at this. Tricks, simple tricks before we end the session. Psi and psi square versus psi versus radius, psi square versus radius, s orbital. The graph should come in this way. For p orbital, you are going to see in this way. Okay, mind it. And you want to say probability density versus radius, you are going to see the curve like this only. Okay, and as n value increases, peak height of the peak increases, number of peaks is equal to n. Number of peaks is equal to n. You can see 1s, 2s, 3s, right? And number of spherical nodes, or you can also say radial nodes, is equal to n minus L minus 1. Number of angular nodes or nodal planes is equal to n. Total number of nodes is equal to n minus 1. You can use this and you can solve the question. Simply you calculate the nodes and you can identify the total number of nodes. So this is your node beta. How to find the node? This is what is called as a node. The dip, the total number of dips is called number of nodes. Are you getting or not? Fine. Any doubt? Okay. So today we had a very good discussion about the total number of nodes and everything. Okay. And I have a question. Now, you tell me the plot of radial distribution curves of the various orbitals of hydrogen atom, radius are given below. The correct plot for 3s orbitals. I want you to give the answer. The last question before we end the session. I want you to give the answer. For 3s orbitals, total number of nodes is equal to n minus 1. So 3 minus 1 is equal to 2. So where I got two nodes, here it is not possible. Here I got only one node, so it is not possible. Here it is not possible. Here one node, two nodes are there. So one node and two nodes are there. Based on this, n minus 1 can give you the answer. So the answer for this question is going to be this. But the students who are preparing for NEET examination, जब आप graphs देखते हैं ना, gone, it's a bouncer, है ना? Now Sonali and Chatki, Betu, and you all tell me, you understand the best trick to answer this node and nodal plane curves? Ashok, and we can have various connections relation to these graphs with quantum numbers as well. The correct plot for 3s orbital. Betu? Yes, the option is going to be D. Agree, Betu? This is going to be, because you in this graph, number of dips is equal to total number of nodes, right? So dip is a node, no? It is a node, and it is also a node. So there are two nodes, I can say. So if you apply this n minus 1 for 3s orbital, n is equal to 3. 3 minus 1 is equal to 2. That's it. Yes, fantastic. So students, if you have any doubts, you please let me know. Today we discussed it right from classical model to modern model. What is the benchmark? That is the Broglie concept and Heisenberg uncertainty principle. Then we started with Schrodinger wave equation. Most of the NEET examination students simply bear this is as a difficult concept, and I discussed this, and I don't want to take into that turbulence. I made you to just attend this class and how to simply classify and clarify these graphs and identify the MCQs based on that. Thank you very much, Betu. Thank you. And hope you like these sessions. Everybody, please like this session, share with your friends, subscribe to Infinity Learn NEET YouTube channel, and we'll meet with more stuff in the next upcoming sessions. And thank you very much. And I'm ending my session and I'm done from my side. Thank you. Stay tuned. Okay. All the best.